Hello, everyone. Hopefully, you all see me. If I could get somebody to give me a thumbs up on in the chat, I'll know this is all working. Good, thank you. Well, I'm just going to give it another minute here to let any stragglers catch up and give me a moment to quench my thirst, and we'll get started. All right. All right, we'll go ahead and get started. So anyway, my name is Paul Balog. Thank you, everybody, for joining. I guess this is our third virtual event now. So yeah, it's actually turning out to be pretty fun. It's a good time doing this. Getting more participation, though, that's for sure, and not just from the St. Louis area. So that's cool. So anyway, let me make sure I got my slides going here. And there we go. All right. So yeah. So again, my name is Paul Balog. I'd like to welcome you on behalf of the rest of the steering committee. We've got Sabri Blackman, Brandon Hunter, and Siju John. Sabri looks like he's online with us right now, and I believe Brandon's going to be joining us here shortly. And Siju, he bailed on us. He had a little one that didn't want to sleep for him last night, so he's a little tired. So anyway, I just want to say thank you to our sponsors. So this evening we've been sponsored always by GoBridge. They've been covering all the meetup fees and whatnot. And tonight, especially because we have a CNCF kind of speaker here, they've decided to go ahead and cover our hosting fees for this session. So that's a good deal. And pardon me. So there we go. All right. So just wanted to start off with some just kind of news and whatnot. It's been a slow month, so with all the COVID and everything. But anyway, I just wanted to bring this up since CNCF is part of this session. Wanted to bring it up that they're having their cloud native survey, and then it's still open. I think it's was talking to Sabri earlier, and then it may be ending this week. So if you want to get word out on what your companies and whatnot are using as far as CNCF projects go, participate in the survey. It's some interesting stuff, but yeah, so please do that. And then here now, the last couple sessions, this has always been postponed. Well, it looks like they have a new date set for GopherCon. It's going to be in November. I probably won't be going, so I won't be able to see all of you there. But anyway, let's hope that this sticks. Hopefully everybody's going to be healthy and, everything's going to be all good so that we can have this in November. As well as this one I probably will be going to, the KubeCon North America in Boston this year. I was fortunate enough to go to KubeCon last year in San Diego, and much nicer weather than St. Louis, let me tell you. But that was really good. Highly recommend it. So, but anyway, I wanted to bring it up. If anybody has any questions or anything that you want to bring up before we start for live session, and you can just throw something in the chat. And also too, we do have on the bottom there's a yeah, no, I'm not looking forward to Boston for the weather, believe me, especially in November. That's not going to be pleasant. I keep wanting to move south, but we'll see. So anyway, all right, so this is our going to be our first lightning talk. And then we have Mitali Bisht, and I'm sorry, I'm sure I butchered your name. I apologize right now. And let me go ahead and get you invited here, Mitali. All right. Bear with me. All right. Mitali, you should see a invite.
Me?
There we go.
Hi, Paul. Thanks for inviting me in.
Oh, yeah. My pleasure. All right. So let's see. You should be able to do it where you can now share your screen.
Yep. So let me do that. I mean, this is first time for me with Crowdcast. So
yeah, it's definitely not the most popular. It doesn't seem to be getting the most use, but
yeah, I mean now it's like all Zoom. So
mm-hmm.
Where exactly is the share thing?
It's there on the. Should be there on the top. I thought.
There's a share, but that is like sharing the event and okay. This is I really cannot see that.
Yeah, I thought if you hover over the center of the screen, it should come up there. Unless I have to close my video.
Yeah.
There we go.
Now I can.
Okay.
Okay.
I may have had too many windows open, and it only allows you. I thought there was 4, so 2 presenters and then 2 windows, but maybe not.
I think it allows only one. Yeah.
Okay.
So I can share my screen.
There we go. Here, and I guess I can go ahead and maximize that. So.
Yeah.
All right.
So okay. Thank you so much, Paul. First of all, and hello everyone. I know I cannot see you all, but I mean, this is now a new virtual way of doing meetup. So before I get started, I just wanted to, tell you guys a little bit story, which is my own experience from where this talk has come about. And I was actually working on one of my Go project, and they were like very tight deadlines. As always, we had like 2 weeks sprint, and we wanted to just get that functionality going. And I was trying to build my module, and then suddenly I saw that there is this. My build actually failed. So, and then it failed for one of the dependencies, which I always been using it, and it gave me a weird error saying invalid pseudo version. So I was thinking, I don't know, maybe something wrong, that version might have removed from the version control system or something. So let me check if I have my proxy set up. So I checked, my proxy was not set up, and I know that I have processed this module in my proxy, so it would definitely have it. So I just changed it to my proxy, and I did the build again, and it again failed for the same dependency, but with a different error this time, saying that it doesn't found in GoSMDB, giving me 404. So then I realized actually I have actually migrated to Go 113 without even realizing that there were some changes. I didn't even read the release notes since I had to get this thing going. So I actually just reverted back to Go 112 and get it go. So the couple of questions that came to my mind at that point of time, that what about the pseudo versions, and what is there in Go 114, Go 113 that has related to the GoSMDB, and that actually is also related to the pseudo versions. So that is my today's talk about. Little bit background about myself. I'm a software engineer at JFrog, working in the community team. Here we actually try to find a solution of different problems that community is facing and try to implement for that. I'm one of the developer of Go Center. Go Center is actually the first central module, central repository for Go modules. It has a very rich UI. I was working for, with since we have the security data also in for modules. I was working with a couple of Go authors for the past 2 or 3 months to have their module safe. So that's it about me. So before we get started, here's the exciting thing. Now we all are in lockdown. Just wanted, and we are not going to the meetup. That doesn't mean we don't get the swags. So we are actually giving. So every month we do the sweepstakes, and we have May sweepstakes, where we are giving away, two Nintendo Switch Lite. So you can just scan this code, and you will be there in the raffle. At the end of the May, the winners will automatically be chosen and will be informed. And also Paul is giving, 3 Gopher t-shirts.
Yes, here's an example.
Yeah, here, and these are very cool t-shirts. Yeah. Okay, so let's get started. So by the end of this talk, you will know about pseudo versions, about Go 113 pseudo version verification. What are the stricter rules that have been enforced from Go 113 that can fail your build, as it did mine. Fixing incorrect pseudo versions for Go modules, so you can simply, go from Go 112 to 113 and now 114. And what is there in Go 114 and later releases for modules. So I'm keep on telling about modules. What is actually is a Go module. From Go 113, module support has been enabled by default. What does that mean? That actually Go module is a list of packages which are stored in a tree file and which has a go.mod file at the root of the project. And so that go.mod file actually looks like this. This I have taken from one of the module, which is containers common module. So it will have module path, it will have Go version, it will have required directive. Required directive will have all the dependencies that particular module is using. The dependencies will be listed as the module name and the version. So now Go has officially taken module as the default dependency management, and it has been growing very fast, and people are adapting to it more and more. If you have not converted your project in module, you should be doing that, because from Go 113 it would be easier for you to follow the releases of Go. So as you can see here, there are different kind of versions format. So like first 3 versions that you see, it's very common that usually we use is the semantic version. These are the release version. Go actually prefers to have a release version, and module versions can be released by tagging a version in the underlying control system. So the format of this is x.y.z, where the first one it changes based on the API changes that you make. So if there is no backward compatible changes, the first major version changes, which is actually, for example, here it's 0.3.1. So it will bump up to 0 to 1. The second version changes, which is called as minor version, which is actually if there is any backward compatible changes. And the last one is the bug fixes for the backward compatible, which we call as patch version. You can also have a pre-release version with a hyphen at the end and with some string. You can have, like, people usually use alpha 1, beta 1, and all those things. And last, the long ones, the weird ones that you are seeing, those are actually the pseudo versions. And these are the versions that I'm going to talk about next. So what are actually pseudo versions and why we use them, why we need to use them? These are actually the untagged revision. So sometimes what happens that sometimes you're dependent on a project that has not published any of the semantic version tags, or you are developed against the commit which has not been tagged yet. So in that cases, we need to use the pseudo versions. The format of the pseudo version is like this. So basically, we don't need to type this whole pseudo version, as Go command take care of it. If you provide only the commit hash part to the Go command, it converts it to the pseudo version and put it in your mod file, which is also an example of, by the way, a Go module query. So here, the first part is actually the most recent tagged version in commit graph before this commit. The second part is is the timestamp, which is the commit time in UTC. And the last part is the prefix of commit hash generated by the underlying version control system. So again, as I'm saying that we should not be editing the pseudo version by hand. It should be generated by Go command, Go client. So what will happen if there are actually many pseudo version out there. People do that all the time. That sometimes they change the timestamp a little bit here. So for one commit hash, you might find like 2 or 3, and sometimes there are like third-party tools which generate those pseudo versions. So what if you do it? Is there any problem with that? So first, pseudo version also participates in the minimal version selection. What does that mean? That if you have a version string, and if you change that version string, then the pseudo version might appear to have higher precedence than the versions that follows it, and it will pin that pseudo version to in your module, which is actually wrong. And the second part is actually the commit date. The commit date in the pseudo version provides the total order of amongst the pseudo version. So if you change the timestamp, obviously it is the whole sorting, it's gonna mess it out. So that's why we should not be updating the pseudo versions, and Go ecosystem has actually realized these problems. And in order to fix it, they have put a stricter rules for pseudo versions validation starting from Go 113, which is enabled by default, and there's no way to escape from it. So let me first tell you like what was the difference before Go 113 and after Go 113. So before Go 113, if you do go get on any of the pseudo version, with any combination of version string and timestamp, what it'll do, it'll actually resolve it to the latest until or unless that particular commit hash is there in the version control system, and it'll put it in your Go mod file. So you're good. It was totally, forgiving about whatever pseudo version you're putting. But starting from Go 113, if you put a wrong pseudo version, you will actually get this error saying invalid pseudo version doesn't actually match the version control timestamp. So let's see what all parts that it validates from Go 113. So let's take the same example of Go mod file. So the first part, which is actually the version string, whatever the pseudo version is derived, it should be derived from one of the major version or one of its ancestors. The second is the commit time. The commit time should match whatever was the being generated by the version control system. Last part is the commit hash prefix. The commit hash prefix should be the same one that is generated by the Go client or any other system. There are other validation also on pseudo version. If you have a plus incompatible suffix at the end of the pseudo version, it is only allowed if it is only required by that major version, and you don't have go.mod file. And at the end is the checksum server validation. From Go 113, there is, GoSumDB has been introduced. And now GoSumDB actually is a transparent log of files where it has all the cryptographic hashes of your module version. So you can see like in your underlying your root directory along with go.mod, you will have go.sum file also, which has all those cryptographic hashes, and that is actually stored on that server. So whenever you are doing a go get command, it actually validates the same pseudo version validations by checksumdb also. And if it doesn't find it, it finds it wrong, it is not going to serve you the content. So it's going to give you 404, as I told you before that it was giving me when I had my proxy set up. So fixing incorrect pseudo version, what are the ways that you can do it, as you have to do it if you want to move it to Go 113. So there are two things that we have to fix. We have to fix our direct dependencies. We have to fix our transitive dependencies. For direct dependencies, what we can do is that in our required directive, instead of putting the whole pseudo version, we just have to put the commit hash part and then run go mod tidy or go get or any command. What it will do, the go command will actually resolve it to the correct pseudo version and put it in your go mod file. For your transitive dependencies, if any of your transitive dependencies are using, incorrect pseudo version, obviously you can go in the mod file and change it there. For that, you have to use the replace directive. So for the replace directive, for the incorrect pseudo version, you just have to follow the same rule, just put the commit hash part, and then it will automatically resolve through it. So how Go Center as a Go proxy can help? I mean, in the main principle of Go Center is actually to be version agnostic, irrespective of the version we want to serve the modules. And in the same time, we want to comply with the Go ecosystem. So we have found out this problem. We have made changes according to that so that, it will be easier for the users. So what we actually do whenever there is a module request, download request there for incorrect pseudo version, we actually change with the correct pseudo version in the .info file and send it back to the user so that it will be available for download. So as you can see here, that this is the pseudo version that has been put in .info. Now, before Go 113 and after Go 113, let's see the change with Go proxy if you set as Go Center. So if you said Go proxy at Go Center, and if you ask for an invalid pseudo version, which is not correct, which is not there, for Go 113 and below users like Go 112, the change is completely transparent. You can actually see that it will resolve it to the correct pseudo version and put it in your Go mod file. So here at the top, you have asked for something with the timestamp 1023 that has been changed to 441. For Go 113 and above users, it will actually say that proxy wants to return you this particular pseudo version, which is actually correct. So either you can put that pseudo version directly in your mod file and run it again, or you just have to change your Go command to just put the commit hash, and it will resolve it to the correct pseudo version and put it in your go.mod file. So that's how Go Center can also help you to have your version updated. Now we have come from Go 112 to 113, and we know that in March Go 114 has released, and there are some changes. There are some features related to the Go modules that have come up. So what are those changes? So starting from Go 114, you can now define an alternate Go mod file. It can be anywhere in your directory using the mod file flag, and it will read from there. But you need to have a default go.mod file in your root directory in order to define that, okay, this is the root. From Go 114, go get will not allow you to set up the mod flag. Previously, it used to ignore it or gives you the error and ultimately polluting your go.mod file. So Go has realized that we don't want to have it set up by the user. Go get will not upgrade to an incompatible major version automatically now unless it is explicitly required by the major version. This is exciting, as we can see plain text error messages from our module proxies or HTTP or other HTTP servers unless they are in UTF-8 format. And finally, now we have SV and repositories support for in module support in Go, which is actually good. So, and now in August, Go 115 is going to release. That release will not have major changes when it comes to for a developer or a user, as most of the changes are the backend tooling changes. You can always go to and change the functionalities which has been merged and proposals. So yeah, that's it about me. I will have my slides posted to the Twitter, and this is again the barcode for the Raffle. Thank you so much.
Awesome, thank you.
Thank you.
I don't know. Anybody has a quick question or anything? We do have there is that ask a question section. I think that everybody should see at the bottom in case if something's up. Otherwise, we can go ahead and switch back over. Let's see. All right, now if I can share my screen again. There you go. And all right, thank you for putting that link there to the Raffle. because Sabri is going to be on that one. I got to get on there myself, so I got to get that one. All right. So now let me bring Daniel in. Oh, here we had a question, Natalia, about the new way to use Go mod file will default completely be ignored. And I think we already dropped you off, so you can't answer verbally, but there you go. Thank you. I'm going to go ahead and get Dan on here. All right. And Dan, you should see the invite. It should let you in here.
All right. Can you hear me?
All right. There we go. Hey. Yeah. Welcome.
Thank you.
Yeah. We get, you had quite the busy day here today. It seems like you're quite the rock star these days. I mean, you're on the Kubernetes release team. You have the binding status podcast, and so yeah.
I try to stay busy. So yeah, for full context, today we had the CrossPlane Community Day. So I'll be talking about CrossPlane some today, kind of as motivation for a lot of the things I'm going to be talking about. But yeah, we had a big community day today and had a lot of kind of prominent folks in the cloud native community, like Kelsey Hightower and Brendan Burns and some of those folks join us to just give some demos and talks and that sort of thing. So we had a fun day, but I'm pretty tired at the end of it, but excited to have the opportunity to speak here. And Matali, that was a great lightning talk there. So I'll try to follow up with some useful information, but that was really great. I appreciate it.
Keep it going. Yeah.
All right. So let's see. It looks like I can share my screen here. So let me get that going here.
I don't know. We're not sponsored by Sweetwater Brewery, but 420 strain mango Kush wheat ale. It's good stuff.
The good St. Louis breweries.
No, actually, this one, I believe they are Atlanta. So, Ari, I believe you might be in Atlanta, aren't you? So
nice. Yeah. Well, cool. All right. Well, if we're ready, I can go ahead and jump in here. I'm going to go through some slides. I have some slides prepared, but I also will just be looking at some code, and we can just also have a chat as well. So if any folks are in the chat and want to just drop things along the way, I'll periodically look into that and see if there's anything and maybe diverge to something a little different if something interesting comes up. So this can definitely be a conversation between me and everyone else here. But to give you all a little bit of context on who I am, my name is Dan or Daniel Mangum. I'm in St. Louis, but I work for a company that's based out of Seattle called Upbound. At Upbound, I work full-time on open source. So I work mainly on the CrossPlane project, which we'll look at a little bit today. Basically allows you to provision infrastructure on cloud providers or on-prem or anywhere from the Kubernetes API. And we'll talk about why that's valuable in a little bit. Besides that, as Paul mentioned, I also do some upstream Kubernetes stuff, mostly around release engineering, so involved with testing and building out some of the release tooling. So that's an exciting opportunity. And just a plug for that, if anyone is interested in being involved with that, it's a very open and inclusive environment. So if you'd like to contribute and jump in, then you are more than welcome. And you can feel free to message me about that after this talk or about anything else after this talk. You can find me at #Dan on Twitter or GitHub or wherever you want to find anyone. That's mostly what I'll be. So definitely feel free to message me there. All right. Let me make sure I'm focused here on the screen and let's see if I can get this to go away as well. All right. I think that's going to disappear there. Okay, there we go. All right. So mostly what I'm going to be talking about today is writing general purpose Kubernetes controllers in Go. And what I mean by that, that's a lot of words that can mean different things in different contexts. So generally, Kubernetes controllers, also referred to as operators, etc., as you'll see here on this page, are basically just Go programs or any program really. It doesn't have to be written in Go. It just commonly is, that watches and communicates with the Kubernetes API server and takes action based on events that happen there. So I'm going to talk about controllers that specifically, there's a lot of different object types that they could be used for, and how we can write controllers and share some of the logic between them, and also create Kubernetes object types that share similar shapes and properties, to be able to share some of that logic and not duplicate as much code. The reason why this is being presented at a Go meetup is a couple fold. So first of all, Kubernetes is tightly intertwined with Go. A lot of people would say that at least some part of the massive success and adoption of Go is related to its usage in Kubernetes. So if you don't have context, Kubernetes came out of Google based on their Borg container orchestration system, and Go also came out of Google. So it was a natural fit there. And a couple other reasons why it was used. Go is a very approachable language. So if you look at the Kubernetes code base, though it is a relatively complex distributed system, it's actually very approachable and easy to jump in, even if you're not that familiar with distributed systems or Go itself. It's a very readable language. And so, yeah, this is why we're going to talk about it at the Go meetup today. And basically, the two things we need to cover before we jump into the Go part of this is how you actually go about extending Kubernetes. So, right, Kubernetes is in charge of container orchestration. That's not actually what, for instance, CrossPlane does and a lot of other projects do. So you need to be able to extend that to do other things. So a while back, I don't remember the exact version that was introduced, but basically the custom resource definition type was introduced that allows you to add new object types. And we'll talk about what some of the existing object types in Kubernetes are, as well as add controllers, which I also said can be referred to as operators or reconcilers, to basically watch those objects and take action based on their behalf. Essentially, what you're doing is encoding operational logic that is usually handled by like a sysadmin or someone like that, who's provisioning systems, setting up infrastructure, and you're putting that into a declarative system. So we're going to look at how that's done a little bit, but that's the general purpose and what we're striving towards here. All right, so as I mentioned, we want to give a brief look at what objects already exist in Kubernetes. So basically, every object has some metadata that's consistent across them. And you can already start to be thinking about this of embeddable types in Go. So basically, all of these different objects have these embedded fields. So you'll see the API version, kind, metadata, and spec. It's basically just saying the group and version of the API. The kind is the object type, obviously, and then metadata is where you put things like names and namespace and labels. And then the spec is where you actually put information that's specific to that object, where you're basically doing that declarative configuration that the system is going to use to take action on your behalf and drive the status, which we'll look at in a little bit, to your desired spec. So some of these common objects are obviously related to container orchestration. So that would be pod, deployment, service, replica set, and there are a few others as well. Basically what these are different ways to get containers running in different configurations. So for instance, a deployment is kind of a wrapper around a pod where you can set multiple replicas and do some other things. And it will also spin pods back up for you when they get killed and that sort of thing. Service is how you expose a service that's running, whether it be a load balancer, a node port, or something like that. And replica set is has some similar characteristics to a deployment. But if you want to read more about these and how they're used in Kubernetes, definitely check out the documentation. These will all be listed kind of in the introductory sections there. But basically, these are all about getting workloads running somewhere on a node somewhere in a containerized fashion. And Kubernetes internally actually has controllers that watch these objects and do the things necessary for that. So when you the tool for interacting with Kubernetes is generally the CLI kube control or kubectl or kubectl, or we can have fights all day long about what you want to call it. And so basically, kubectl, that's the, Sabri says no. So I don't know which one he thinks it is, but I say kube control. So maybe, y'all can fight me after this. But anyway, the Kubernetes does have some built-in controllers. So when you create these objects with kube control create or apply, then it's going to see those. If you modify them, if you delete them, etc., it's going to take action based on that. So in these specific use cases, it's going to take your container image and start it running on a node where container runtime exists and that sort of thing. All right, so this is basically pulled right from the Kubernetes documentation. This is the architecture that you would think about in Kubernetes. You don't have to understand it extensively for this talk, but I do want to show it because it's going to show how we're going to integrate with it. So you see the main components that we're thinking about there, and you can think of the Kubernetes control plane. Think about this as a single machine, for instance, where you have these different processes running. So the Kube API server is kind of the central communication point. You can have multiple Kube API servers running, but for simplicity, let's just think of it as one. etcd is just basically the production level key value store, where we store the information that's in those objects that we're creating. And then the scheduler and kube controller manager and cloud controller manager all do things related to scheduling and provisioning resources onto nodes, or creating, in the cloud controller manager case, creating load balancers and some of those sorts of things. Then you have, since Kubernetes runs in a cluster fashion, you're going to have different nodes which are actually in charge of running the workloads. And on those, you have the kubelet, which is basically the core process running on there that Kubernetes communicates with, as well as the kube proxy, which serves as the software-defined networking layer. Once again, if you want to learn more about this, definitely follow the link there, or just go to the Kubernetes docs in general, and we can find some more information on that. But when we go and we extend Kubernetes, essentially what we do is we add our own controllers that communicate with the kube API server. So, yep, you can add your own controllers. So basically you put those in there, and they're just also programs that are running and communicating with the API server, specifically being informed about events on certain objects that they establish watches for. And they can also do things like create more objects, which obviously trigger other controllers. And you can also get into cases, where multiple controllers are fighting over objects. So these are all things you have to work out in a distributed system setting. But as you can see, those controllers talk to the API server. So generally, when you look at Kubernetes projects built on top of Kubernetes, CrossPlane being one, they'll come with some CRDs, so basically new types, as well as some controllers to watch those types and take actions on them. A common way that this is described is you're basically, when you create custom resource definitions that add new object types, you're basically adding API endpoints. So think about your favorite API that you curl on a regular basis, and the different endpoints that it has to get information back. Basically what you're doing when you create a custom resource definition is you're just adding another endpoint there, and it comes along with some create, update, delete actions and that sort of thing. All right, so as I mentioned, a custom resource definition is how you add the new types. A custom resource definition itself is also an object in Kubernetes, so this can get a little bit meta here, but essentially what you do is there is a controller that is in charge of adding these new API endpoints to the API server, and it watches custom resource definitions. So when you create a new custom resource definition, you're basically specifying an open API v3 schema, which is going to be the schema for the objects instances that you're going to create after that. So if I want to create an object called myType in this case, and you'll see it's in the St. Louis Go or stlgo.io namespace, that there's actually going to be a new object created in our cluster. So if you want to try this at home, you could actually take this code right here, and kube control apply it. And then you'd be able to create actual instances of my type. You'll see that it takes some standard fields like group and name and scope, which are all required. And then the validation section is basically where you define how you want to do validation on that object when instances of that object are created. So you'll see here, for instance, in the properties cool field, which is a string, is a required value. So the API server will do validation for us there if we specify it in the open API v3 schema. You're probably familiar with this kind of schema if you've defined, JSON endpoints and that sort of thing before. It's all the same. One thing I want to point out here is the scope field. So you'll see the scope is cluster on this object. So basically what that means is that these exist at the cluster scope. So in Kubernetes, you can either exist at the cluster, the namespace scope. Namespace is just a form of isolation in Kubernetes clusters. Many things like deployments, pods, those sort of things exist at the namespace scope. Organizations will use those in a variety of ways. It could be isolating teams, isolating environments, all sorts of things like that. There are some very bad practices you can get into with using namespaces to manage things, especially around security. But in general, it'll be pretty clear whether you want something to be namespace scope or cluster scope, depending on what you're going to do with it. You'll see later on in CrossPlane, all of our managed resources, which represent external managed services on a cloud provider, are at the cluster scope, basically because they exist outside of the context of just a single namespace, something like that. They're infrastructure that exists, and then we consume them at the namespace scope, which we can look into that a little bit more later on as well. All right, so as I mentioned, that CRD that I just showed there, it would allow us to then be able to create a manifest like this, where we have defined the necessary fields and it's kind and API version, etc. So we could then create those in our cluster, and if we had controllers watching that, maybe we'd take action based on that. A good example here is one of the demos I did early on when working on CrossPlane using our framework called CrossPlane Runtime, which I'm going to be covering later on, is create a CRD that represents a Slack message. It was basically no more complicated than this here. There's a few other fields, but essentially what it did is there's a controller that watched for creation of type kind Slack message, and then there's a string there, and it posted that message to Slack. So that's probably not a very useful use case, but it does kind of motivate in a simple manner what you can do with these sorts of things. So as I mentioned, there is the spec and the status in an object. Generally, you can think of what the spec of the object as what the user defines, and the status is what the machine reports back. So generally, and once again, we'll talk about some use cases where this is not exactly true, but generally the machine, or the controller in this case, does not modify the spec of an object, but does modify the status. Likewise, the user does not usually modify the status, but will set the spec. So the spec is the declarative configuration, and the status is the current state of that object. So you can think of this happening in reconciliation loops. So when an object gets created, maybe on the first, it takes a couple of reconciliations essentially for us to get to the desired state. So maybe on the first reconciliation, we take one step and then we add the status, say, maybe we're in the provisioning phase, and then we take another reconciliation step where we check to make sure some external service exists, like a Slack message. And if it's there, we say, created stage. And those would be encompassed in the status. So generally think of the spec as things that you define as configuration, and status is what the machine tells us back about the state of that. And you'll see here controllers are idempotent. So that's very important in a distributed system, as you don't want different behavior based on different specification. Trying to think of a good example of this, maybe something like, if you are provisioning a database, you want it to happen the same way every time. If not, then you can't reason about it and make declarative configuration to make sure that happens. So that's something to keep in mind. Generally, the things that you are using custom resource definitions to define will naturally kind of fall into that category anyway. All right, so we talked about a very simple example with a Slack message, but let's think of some more useful examples that are popular in the Kubernetes community. So one of them that I like to point to on a regular basis is Cert Manager, a project from JetStack. And basically what it does is it acquires certificates for you in your cluster. So this can be useful, obviously, as you have many things that need TLS encryption and that sort of thing. And so being able to do that natively in Kubernetes alongside actually deploying those workloads and provisioning those services is incredibly useful. If you want to look at some of the CRDs that they use, for instance, they have a kind certificate, then that's really useful. Another one, Open Policy Agent, or called OPA frequently, is for creating policy. So essentially you can create CRD types with their gatekeeper operator that allows you to essentially put boundaries on what other folks can create, so other object types. So for instance, at CrossPlane Community Day today, we were showing provisioning a database on GCP, and we created a policy with Open Policy Agent and its own CRD that basically said you can't create a database larger than 30 gigs or something like that. And that restricted the creation of the resource itself. Some other ones here, Knative, basically a serverless project that allows you to deploy serverless functions on Kubernetes. So basically taking you an abstraction higher than the containerization level. There's some interesting things around that. A Knative service looks very similar to a pod, but does some interesting things like scaling to zero and handling cold starts and things like that. And then lastly is CrossPlane, the project I'm most familiar with and work on a daily basis. And it does infrastructure management, so provisioning, updating, keeping your infrastructure running on different cloud providers and different platforms. And as I mentioned here, some of these projects only talk to Kubernetes, others reach out to other APIs. How you can think about that, the middle two there are mostly just talking to Kubernetes, right? So Knative is basically providing an abstraction on top of the primitives that Kubernetes provides to be able to do some of that cold start management and scaling to zero and that sort of thing. Open Policy Agent is just handling things that happen within the cluster in terms of policy, or at least before they go out to an external API. Whereas CrossPlane, on the other hand, when you create an object that CrossPlane's watching, we're going to actually call a cloud provider API like the GCP, AWS, Azure API, etc. And that is going to lead to the creation of something elsewhere. So we have to handle both these objects that are in Kubernetes as well as external things that are being provisioned, making sure those are brought to a good state there. And a lot of things, if you're writing controllers to manage certain things within your organization, especially infrastructure, are going to reach out to external APIs because most of the abstractions within Kubernetes have either already been addressed by another project or are kind of handled by the native Kubernetes types themselves. There are some other opportunities to do things there as well. Basically, anything that happens on a node itself might be something that stays within the Kubernetes bounds in terms of reaching out to an external API. Okay, so when you're working on a project that's extending Kubernetes, a really important distinction is adding an object versus expanding an existing one. And I actually feel pretty well positioned to talk about this because we have taken quite a bit of criticism for the number of objects that we offer, mostly from folks who don't understand exactly what we do in CrossPlane. But basically, we have different object types for every type of managed service you can imagine on cloud providers, and we'll see that that's a lot of them in just a moment. But GCP Cloud SQL instance, GKE cluster, AWS RDS instance, Route 53 configuration, et cetera, whatever you can imagine that you use on a cloud provider, that's represented as an object by CrossPlane. And the reason why we have so many is because they kind of check one of these boxes here. So the four things that I like to look at when I say, should we add a new type, and some of these are a little bit more important than others. So the basic one, the logic to manage it is significantly different than existing types. So if it's just a completely unrelated thing that's not handled by another object, then you may want to add a new type. A lot of times you can actually do things like, when you put a specific annotation, which is a type of Kubernetes metadata on an object, then you can just take action based on that. So you don't have to add a new object type. You can just say, if there's an annotation on this existing object type, then I'll go do this separate process that's related. The two middle ones here are the two that I really want to focus on, though. So I mentioned that Kubernetes provides RBAC for you. So this is one of the values of using it, is you kind of get this RBAC built in. RBAC is isolated on kinds and group types. So when you specify RBAC policies, essentially you're granting permissions, which are just verbs. So, get, create, update, delete, etc., to different users or groups within Kubernetes. So if you want to actually isolate RBAC permissions for a group, or for an object, then it needs to exist separately from other objects that may have different permissions. So a good one to think about here, in CrossPlane, we not only provision infrastructure, but we also allow you to schedule workloads to Kubernetes clusters specifically. So you can think, if you provision like a RDS instance on AWS, you just kind of provision that, you get the connection information, you connect to it. If you provision something like a GKE cluster or maybe an AWS EC2 instance, that's not just something that you consume from another thing. You actually schedule things onto that. So in the instance of a Kubernetes cluster, a managed Kubernetes offering, we separate the actual object of the Kubernetes cluster, which is the provisioning, and the consumption of it, right? Because some people may not have permissions to provision a Kubernetes cluster, but they may have permissions to consume one. So essentially, we have something called a Kubernetes target, which allows you to schedule to it. It's not really important what's happening behind the scenes there, but the main point is there are different personas that would do these different actions. So it makes sense for them to be operated separately and be in different types. You can also kind of, do some of your own permissioning on top of Kubernetes. But as soon as you do that, you kind of lose this integrity that Kubernetes provides with their RBAC. So as soon as you start layering things on top or circumventing existing things, then you have a whole nother world of trouble that you have to deal with there. Not saying you should never do it, but you just probably shouldn't. So keep that in mind if you are attempting to do that. And the other one here that I wanted to touch on, the last one is kind of self-explanatory, but existing a different scope. So we already mentioned that as well. Something should exist in namespace versus cluster scope. That's a binary field on a custom resource definition. So if you need a difference there, then that is something definitely to consider. Specifically, the reason why it's important to have a difference between namespace and cluster scope object is object references and owner references, which are built-in Kubernetes things that basically allow you to do garbage collection when an object is deleted. So if something is an owner of an object and it gets deleted, then Kubernetes will garbage collect those child resources for you. The issue with that is a namespace object cannot be the owner of a cluster scoped object. So if you need that kind of relationship between the two and you want to take advantage of Kubernetes garbage collection there, then you need to think about if you need separate objects there and how to handle that relationship. Once again, you can do your own sort of garbage collection here within your controllers. This is something that I would say is a little bit more advisable. I've run into more cases where this is an appropriate thing to do. And actually, Kubernetes garbage collection can be a bit unintuitive in some situations. It's not quite as dangerous to get into that, but just be aware that you could be orphaning resources and that sort of thing. So if you are doing that, keep that in mind. All right, so if any of those cases above are true, then it may make sense to add a new object type. All right, so as I mentioned, I work on CrossPlane pretty much with the majority of my time. So CrossPlane allows you to, as it says, manage any infrastructure anywhere using the Kubernetes API. API is missing from that sentence, so imagine that it is there. CrossPlane is built in a plugin architecture, so we basically have core CrossPlane, so that's the CrossPlane repo. And then we have different providers. So a provider, you'll typically see things like this in any infrastructure management tool, like Terraform or something like that. A provider is basically just what adds functionality specific for a specific provider. So in this case, we have officially supported providers in the CrossPlane org for AWS, GCP, Azure, and Alibaba Cloud. There are also some community-owned providers, but these are the main 4 cloud providers that we see usage of, and the ones that we actively support and maintain and basically stamp off as, approved by CrossPlane. So each of these has quite a few different services that they offer. If you use any of them, I'm sure you're already aware of that, and these numbers will not astound you, but it still is kind of helpful to see them on the screen. So these are unofficial numbers that I pulled from doing very quick Googling. But basically, the bottom line here is that there is a lot of them. And if you're creating different objects to represent all of them, writing extensive controllers that handle the full life cycle of those objects gets really cumbersome. And you'll see that because we don't support every service on each of these cloud providers because it would take far too much time, and we have a small team. And so what I'm talking about today doesn't even solve this problem entirely, of course. To completely solve it, we're looking into things like some advanced code generation and that sort of thing, which we can talk about towards the end. But what we are about to talk about does allow us to support 50 or 60 or so managed resources across these cloud providers that are the most commonly used ones, and add new ones with pretty little churn. So that's why we want to talk about these general reconcilers today. All these managed services on these different cloud providers have a general pattern for reconciling them. You create them, you watch to see if they change. If they change, you update them back to the desired state. If the user updates the spec, then you make that update on their behalf on the cloud provider. If the user deletes the object, then you delete the object for them, depending on the deletion policy, etc. So they follow this general pattern. But then for each provider, they're obviously calling out to different APIs. They have different SDKs that allow you to interact with them. And they also have just some different intricacies across resources. So when you're writing controllers to manage the lifecycle of all these managed services, you'll quickly see that cloud providers do some really crazy things behind the scenes. And you will actually probably have nightmares about some of the things that they do. So there is a lot of strange behavior around creating, update, and deleting resources. Some resources are entirely different from others. So for instance, an IAM role is very different than an RDS instance, and creating and updating, deleting one looks very different. So when you're thinking about sharing a reconciler between objects like that, you have to find the lowest common denominator. So you want to abstract away as much of that as possible, while also allowing the necessary level of customization there. And we do that, as we'll see later on, by basically providing a lot of sane defaults when you're writing controllers. So basically we'll say, in most cases, this is the best way to do this. In the case where that's not true, then you can override it and pass in your own kind of logic there. All right. So as I mentioned, these managed services are many objects, but they have a generally similar shape. So we don't want to reinvent the wheel for each of them. So I talked a little bit already about controllers, which we're going to talk about a little bit down the line, but specifically looking at sharing shape among objects. We already talked about earlier on that every Kubernetes object has this API version, kind, metadata, and spec. And those are fields, well, excluding the spec here, that are shared across all object types. So generally, Kubernetes CRDs and controllers, well, specifically the CRDs are generated from Go code, so they're defined as Go structs. And then you have these JSON tags here that inform code generators basically to create these YAML definitions, which are custom resource definitions. And we can take a look at some of those later on. But basically, writing these in Go allows us to take advantage of some of the primitives that Go has. Specifically, what we're looking at here is type embedding. So you'll see this meta v1 package is basically the Kubernetes object meta package. So from Kubernetes. And what we're doing is embedding those in our my type here. Having those present allows us to, well, first of all, it'll bring along those object types. So type meta has like kind and API version and that sort of thing. It'll also allow code generation that we use to generate some methods that will satisfy interfaces, which basically are required for Kubernetes to accept these objects and do the reconciliation it does on its side. So the main things we're looking at here is the type embedding as well as the interfaces. And as I say there at the bottom, all CRDs make use of these. But what we're going to look at is, besides just these meta package types that we're bringing in and embedding in our types, we're also going to bring along other types, which allow us to do similar things and share some logic across our reconcilers, and also use common interfaces. All right, so I briefly alluded to this. Go is great for code generation. It has very native support since 1.4. You can read a little bit more at that link. And you can also write your own generator, which is what we do for CrossPlane, since we have a lot of different providers and types, where we generate some methods for you. When you embed these types, we'll generate methods that allow them to satisfy interfaces, thus being able to take advantage of shared code. Controller runtime is the Kubernetes SIGs project that basically does a lot of the logic packaging for controllers, as well as some of the code generation for CRDs for you. So definitely check that out. I believe it's Kubernetes SIGs / controller runtime. And we'll see kind of how that plays out here. Specifically in this tree here, you'll see the ZZ generated deep copy.go. That's something that controller gen, which is part of controller runtime, will generate for you, which basically allows it to manipulate those objects. They're deep copy functions, so you're probably already familiar with what's happening there. All right, so this is just showing go generate here. So basically you'll see whenever we run go generate on this file, it is running controller gen there from controller tools, as well as CrossPlane tools, AngryJet, which is basically just our generation framework that will generate some of those for you. So this sits at the top of all of our custom resource definition files. We're going to look at an actual implementation of this. It won't just all be code snippets here. But you'll see at the top, we basically remove all of the generated CRDs, and then we regenerate them again when we run go generate. Something that I think is really cool that you can do in Go, which I actually wasn't familiar with until maybe a few months back, is kind of pinning these generation frameworks here. So these are not actual dependencies that are used in your code, but you'll see here in the import statements that we have anonymous imports, which basically make sure that those are pinned, so we can pin those in our Go mod to the specific versions we're using. And so when someone, a new contributor comes along and they want to use specific versions, or they're adding a new provider and want the same generation to take place, then they can just pin them as well and make sure those versions match in the Go mod. So that fits pretty well with what Matali was talking about earlier. All right, so what we're showing here is an interface that we define for all of our managed resources, which are those object types that represent external infrastructure. And you'll see actually within the interface itself, we're doing type embedding. So we actually share some of these embedded interfaces with a few other interface types. But just to kind of touch on some high level ones here, the provider referencer, we have a provider object for each provider you can install, which basically points to a secret with connection information to be able to authenticate to the API. So obviously every managed resource, in order to be able to be created, needs to be able to authenticate to the API that you call its creation method on. Connection secret writer to, this is basically exactly what it says, saying where it wants the connection secret to be written to. So we'll see later on in our controllers that we basically call that method connection secret writer to, and then create a Kubernetes secret with the information we get back from that. And then another one here, there's a couple we're not going to touch on, but conditioned basically gives us a uniform way to report on the condition of resources. So different providers, like cloud providers, will tell you condition that varies even amongst services within a single provider. We want a general way to report on if a object is, or an external piece of infrastructure is ready to be consumed or not. So we have some generic conditioned methods and fields that we place on all of our managed resources. Okay, so as I mentioned before, controller runtime provides you some abstractions on writing these controllers. Specifically, it gives you a controller manager, which you can basically register multiple controllers in a single process or a single Go binary. And then you register those different controllers with the manager. So you'll see here at the top, we're doing this setup where we pass in the manager and we say, what type we want to watch and that sort of thing. So this actually abstracting away a ton of things that are happening behind the scenes here. If you get deep into writing controllers, you may think about not using this eventually because some of the abstractions will break down at some point. That being said, we actually still use components of controller runtime and CrossPlane. and we have to do some pretty sophisticated reconciliation. So it will carry you a long way. Obviously, always as an open source advocate, I will say if you have issues with what's going on there, then try and fix it upstream before saying it sucks and moving on. So as I say here, this is a nice abstraction, especially the reconciliation loop for resources that do not require complex reconciliation. You'll see it basically is just one method on the reconciler that you pass in. That method is reconcile. So that is all the logic that you'd want to have to be able to take actions on a resource. And then, yeah, so you'll see here, and actually I'll go ahead and go to the next slide. I just noticed down here that there is a 1 by the ask a question. Oh, I see that there is a question here. I will answer that in just a second. The question is, what's the difference between CrossPlane and Anthos or OpenShift? And I will get to that in just a moment after I finish up this slide. All right. So, and I've brought that bar up again. But basically, in the comment there, it says do some stuff. That seems pretty simple. It actually can get quite verbose depending on the resource that you're reconciling. So for instance, a use case that I've heard recently is that someone needs to get an IP address within their physical data center within their organization. And that can actually be quite a complex operation that depends on a lot of other systems. For instance, in this case, it depended on actually opening a ticket on a ticketing system, getting that approved by a human, and then reading that back, and then actually going out to a separate system, requesting the IP address, and doing some other things before they actually got a value back, and it was actually provisioned and wired up correctly. So a lot of things can happen there, which is totally fine if you're just doing, kind of a one-off resource there. And, there's no really reason to write shareable things if you're only going to do it once. Except for that it's sometimes easier to test with your unit tests, and also can be a little more visually aesthetic and easier to work with down the line. But in general, this is a fine abstraction here for objects that are not too complex and are only going to be, objects of that type are only going to be used once. But as I say here, this is not a great abstraction for resources that are sufficiently complex. All right, we're going to take a moment here and answer some of these questions, and they are great questions, let me say. So Anthos and OpenShift versus CrossPlane. Anthos, it might be Anthos, I never know, but Anthos, I honestly cannot answer that because I don't exactly understand what it is. From what I understand, it's like Google's take your Kubernetes home with you. And that's basically my extent of the knowledge. I don't think it's open source, so I really can't tell you much more than that. But we are not a Kubernetes distribution, so that's really important. We are completely a Kubernetes add-on. It says it on the front of our README. We are not looking at making a Kubernetes distribution whatsoever. We are simply something you plug into your Kubernetes cluster to get infrastructure management with it. That also kind of answers the OpenShift portion of that. We actually, if you want to check out, and the video will be available soon, we had 3 folks from Red Hat presenting on actually running CrossPlane on OpenShift. So OpenShift is a Kubernetes distribution for folks who are not aware, and it has some kind of additional enterprise features that are quite nice, but we just integrate with them as well. And let's look, does CrossPlane overlap with Cluster API? Great question there. And one I would like to point you to, I will get it later, so remind me if I do not. But I actually have a link to our live stream show we do where we actually have a show with one of the maintainers of Cluster API, where he and I basically show how CrossPlane and Cluster API interact with each other. So for folks that aren't familiar, Cluster API does something that's sort of similar to what CrossPlane does, but in a very, very scoped fashion. So basically what it does is it allows you to create Kubernetes clusters from Kubernetes clusters. Typically that first cluster is called a bootstrap cluster. So it may be something like a kind cluster, or could be any cluster, Minikube, etc. Those are just kind of ephemeral options, so they're commonly used. And it basically allows you to define new Kubernetes clusters with CRDs and that sort of thing. It is interested in actually provisioning Kubernetes clusters using kubeadmin under the hood. So it's actually like spinning up nodes and that sort of thing. We're not interested in doing that. We may allow you to provision EC2 instances with CrossPlane, and you may do some things to stitch those together and actually get Kubernetes running on them. But we actually only provide managed services to you. So for instance, Cluster API does not spin up a GK cluster for you. It actually spins up VMs on GCP and installs Kubernetes on them. So that's the difference there. You actually can in the same cluster. We don't call ours a bootstrap cluster because a CrossPlane cluster would be long living. But you could have Cluster API. This is what we do in the TBS episode. You could have Cluster API running as well as CrossPlane in a cluster. Spin up a kind of self-managed Kubernetes cluster with VMs and that sort of thing with Cluster API, and then actually provision workloads to it using CrossPlane. So you can actually run workloads on your Cluster API cluster using CrossPlane and something we call a Kubernetes application, which is basically a wrapper of config that we send off to a remote cluster. So great question there. I'm glad you brought that up. Another one here, and I'll try not to get too bogged down in these, but these are really awesome questions, so I do want to touch on them. Instead of controller runtime, what would be pros, cons of using Operator SDK, KubeBuilder, or Kudo for writing operators? Okay, so I'll take each one of those kind of in order. Operator SDK, maybe controversially, but it's mostly dead, confirmed by some Red Hat folks today. But it generally does some of the sort of things that controller runtime does a little bit. So I'd say those are more parallel. As I mentioned, we use controller runtime and build some abstractions on top of it, and also do some things that are separate from it, but that's not important for this talk. But so we would highly endorse using controller runtime. KubeBuilder is actually basically a code generation tool or file structure generation tool that basically just uses controller runtime and controller gen and some things and sets up the project for you. If you want to use KubeBuilder to write CrossPlane controllers, for instance, you are more than welcome to. It does some weird things, again, that we don't love, but we actually use the same generation under the hood. So we're basically you're either using the CrossPlane CLI or KubeBuilder to generate the files. We're not really we don't really care what you do. And then Kudo, I'm not as familiar with Kudo. I believe it's focused on some sort of application management. I did work with one of the maintainers of it for a little while, but I don't have enough context on there to provide a valuable answer. But I'd be happy to do some more research and follow up if you ping me after this. And last one here. Can you speak a little bit about Ansible operator versus custom? I'll probably need a little more context on that question. I assume that by an Ansible operator, you're talking about a Kubernetes Ansible operator. But if there is an Ansible Kubernetes operator, you could use that with CrossPlane as well to basically provision resources. Basically what CrossPlane does is it takes these different provider types and allows you to build abstractions on top of them. So you can basically have a, let's say an RDS instance and a Cloud SQL instance, and you can provision them using the same primitives. So you can like build a Postgres instance type on top of it, all of this without writing any code. And do that. So if there's Ansible primitives as well, those could be wrapped in. So maybe you could do something like having, if there's an Ansible CRD type that's for provisioning or for doing some setup on like a VM or something like that, then what you could do is you could provision an EC2 instance with CrossPlane and then use an Ansible object type that points to that EC2 instance to do some setup on it. And you could actually bundle those together and provision them as one single unit. It looks like some other folks are helping as well. And could you put some light on custom controller testing? And this is the last one I'll answer if more come in before we move on. But these are awesome questions. I'm very happy with them. Yes. So obviously you can do unit testing on custom controllers. That definitely makes sense. Another, and that probably is not helpful for me to say that. But when you're talking about actually doing integration tests on custom controllers, that is quite hard depending on what they're doing. So if they're only doing things within Kubernetes, you can spin up like a kind cluster or any other thing, or just in the API server binary itself and an etcd. That's actually what KubeBuilder sets up for you. If you want to use their package is called env test. If you want to use theirs, they actually just run the API server and etcd binaries for you. And essentially what you do is you actually just do operations against the API server and check that certain things happen. I prefer to use like a kind cluster just because it's a little bit easier. We have some integration testing framework actually built into CrossPlane runtime, which we're not going to look at today, but we will look at CrossPlane runtime today. So if you want to look at that and you have any questions for that, I'm pretty, very, very familiar with the things we do there to test our custom controllers. So I'd be happy to provide any additional context there. All right. And also, Paul, I know that I think we have a 2-hour block here. So I'm just going, but, just tell me to be quiet and go home if you want it at any point as well. But I'm trying to give you your money's worth here. So
appreciate it.
All right. So let's go ahead and move on. And I'm sorry, this is going to bring up this again. Oh, that's actually kind of nice. Actually looks a little bit better. All right. So this is kind of a joke, but actually not really. I was using Carbon, as you probably saw from those other code snippets, to generate nice pictures, so it wasn't just text there. And I tried to do a picture of this controller we have in CrossPlane and Core CrossPlane, which is a very old controller, but it's just kind of like a one-off thing that doesn't have any shared logic. And I copied all the code into Carbon, downloaded the picture, and then I tried to import it, and the file size was too large. So that's basically just to demonstrate that the controller is quite large. We can actually look at it here. Well, actually, it looks like it is not coming up. Y'all still see my slides, right? All right. I'm going to close video real quick and do this again. Share. Let's see. Last time I had an option to share video. I'm trying to remember where it was. Oh, here we go. Share screen. Application window. Nice. All right. So it looks like before I was doing Chrome tab. So this looks to be better. All right. So now I can show you both my slides if they load and this file. All right. Sweet. So this is basically what I was taking the picture of. This is a very, very long file. You'll see that setup and then the reconcile. And actually our reconcile is very short, but that's basically just because it shells out to this factory here, which in my opinion, you don't really need a factory in this case. It's just only one thing. But anyway, it just goes on with a lot of logic for quite a long time. This is actually only doing things within Kubernetes, not reaching out to any external APIs or anything like that. And you'll see here that there's quite a lot of logic. All right, so let me hop back over the slides and see if there's much more to talk about. Okay, no, this is actually the last slide. Besides besides the Q&A slide. So what I want to do is actually look at CrossPlane runtime, this thing that I have kind of been alluding to this whole time. All right, so this is CrossPlane runtime. This is our layering on top of controller runtime. And the thing I want to show in here today, well, actually, maybe let's start with this APIs directory. So I mentioned that we have some embeddable types that we do across different resources. So if we look in resource.go here, you'll see some of these things we talked about. Specifically, I want to look at a resource spec. So this is in all managed resource types. So these are basically fields that will be present on all. You'll have something like write connection secret to ref. So we have those on all managed resources, even if there's not really connection information. It's just standardization. If there's no field provided there, we actually just don't write any secret, but it basically provides an interface for writing a secret if there is connection information available. We also have claim reference, which we're not going to get into claim in class today, but it's basically ways to do dynamic provisioning of things later on down the line. And then we also have provider reference, which I mentioned earlier. Provider reference is an object ref to a provider type that shows you how to authenticate. So that's just an example of an embedded resource type. We'll also see maybe that we have condition is kind of helpful here. So these are some of these conditions that we put on all managed resources. So as I said, cloud providers report back, like when you are provisioning a Cloud SQL instance, it's going to say something like provisioning, and then an RDS instance is going to say something like creating. There's all these different terminology that cloud providers use. But we also, we propagate that back to the user, but we also say things like ready or synced, et cetera. So we have our CrossPlane language about talking about that. And also it looks like there is a bit of a blur when I'm scrolling, so I'll try to stop at anything important here. All right, but you'll see some of these types here, and you'll see this condition struct. So this is basically the conditions that we embed in the status of a resource, so that you can make sure to have these common types present. This is really valuable if you're doing something programmatic with these resources, right? So you can have these kind of guaranteed fields that represent the state of the resource. So let's say I want to, well, a good example, we'll try to go off what one of the guests was asking about integration testing. So something we do sometimes is we'll say, wait until condition ready is true. And we have that guarantee across all our managed resources, so we can write that as a generic test and then run a bunch of resources for it that, you know, wait for ready is true and then delete the resource or something like that. So that's just an example. All right. But what I really want to look at is this reconciler package here. So you'll see a couple of these here. The main one I want to look at is the managed reconciler. And this is quite a big file as well. And I was kind of hating on that other controller. But what you'll see here is that this is quite a lot of code that allows us to do things like have a GCP Cloud SQL controller that is pretty sufficiently complex of a resource that is a rather, well, I'll let it catch up here. That's a rather short controller here. And I'm not stopping just because I'm not talking about the actual things here. We're going to come back to that. But you'll see there's not a ton here for a pretty complex resource. And the reason why we're able to do that is because we use this shared reconciler here. So if we look at the Cloud SQL controller, we are going to go up and we're saying manage.new reconciler. We don't have an actual reconciler object here like we did over in this CrossPlane package one, where you'll see we just had that controller runtime reconciler type and all these things in it. We just call managed.new reconciler and pass in some things to it. And it kind of takes some of these for us. These are also things that you can just do defaults for. So you can actually just do a manage new reconciler. I believe the only required arguments are maybe the manage kind. And it will actually just use defaults for the rest of it for you. All right. So looking at the manage reconciler, what are we actually doing here? What we're essentially doing is instead of exposing just a reconcile loop to you, we're scoping down the responsibilities of each of the logic that you write into basically CRUD operations. So it's not CRUD, it's actually OCUD or something like that, however you want to say it, but observe, create, update, delete. And so we're basically saying, just tell us what we need to do just within the scope of talking to the cloud provider in these sections, and we'll do the rest of it for you. So you'll see we have quite a lot of things here like connection publisher. So this is how we handle something that's Kubernetes internal that's standardized across all of our managed resources, where we're creating a secret with connection information. So that's something that we don't have to do in every single controller that we write. We just fall back on this default connection publisher that we have. Since this is an interface here, you can pass in your own connection publisher. So you could also write a controller, and we'll definitely be doing this later on, that maybe does something like instead of writing a Kubernetes secret, it writes secret information to Vault that you have, a connection to or something like that. So this is very pluggable and allows you to do a lot of things with it. In fact, there's actually quite a few people who are not CrossPlane users that just come and use CrossPlane runtime because it has some really nice built-in machinery for you. Initializer, this does some interesting things. Oh, actually, let's look at reference resolver. In CrossPlane, you can actually create lots of objects together in a cloud provider. Also, thanks for dropping that link in there, Paul. In CrossPlane, when you have lots of different managed resources, a lot of them are usually dependent on each other. So a great example of this is if you want to have a GKE cluster and a Cloud SQL instance that talk to each other securely within the same network, you obviously need those to be in a network. And when you actually create the Cloud SQL instance, for example, you have to specify the network that it's in, and that has to already exist. Well, we want to enable, good GitOps workflows and that sort of thing. So when you create objects that reference each other in CrossPlane, it will basically work out those references for you. You don't actually have to implement that as a provider writer, though, someone who's writing these controllers. We actually just say, use this standard reference type, and we will make sure that all the references are resolved before we try and provision the Cloud SQL instance, for example. So if you looked back at the provider GCP repo, you'd see that the Cloud SQL instance has some ref and selector types, which are basically references to other object types. So for instance, it has a network ref field where you can reference a network that you're provisioning at the same time as it. And when you do that, CrossPlane's basically going to go look and find that network object and then see if it's ready to be consumed. And if so, then it will allow you to actually provision the Cloud SQL instance. So just another thing you do there, once again, pluggable. So you could put in your own reference resolution in there as well. Same thing with external connection. The first thing you do is you basically get a client for the cloud provider you want to talk to, and then you return an external client, which has these observe, create, update, and delete functions or methods. So this is actually what you could do here is you could implement your own external client interface and pass that in if you wanted to. So once again, extremely pluggable. Probably going into too much depth on that, but I just want to emphasize that this adds a lot of functionality, but doesn't lock you into using it. All right. I want to, lastly here, before we wrap up, I want to look at the actual reconcile method here in this shared reconciler and look what's actually happening here. And then we'll look at the provider GCP Cloud SQL instance controller and show how that's getting utilized. So this is following traditional reconciliation patterns of getting the resource for which we were triggered the event for. So we get a reconcile request, which basically has a name and namespace, and we're going to go get that object. We call this new managed method because this works for lots of different kinds. So basically new managed is going to return us the type that was passed in with the managed kind here. So in this case, for the GCP Cloud SQL instance, it is going to return us a pointer to a Cloud SQL instance type. And then we're going to get that. So when we get it, we're specifying the namespace and name. It's actually a cluster scoped object, so namespace is not important. But we're basically going to get into that object. And then we're going to do some log messages. Next thing we're going to do is we're going to call the external connect method. So I mentioned that the first thing you want to be able to do is connect to a cloud provider. So you'll see here that we pass in with external connector here. And this is our Cloud SQL connector, which just has this one connect method. So you'd see earlier that we had this external connector interface. So we're basically satisfying that here. We have a struct type that has a connect method, which is the only requirement for that interface. And in it, we are getting the reference to the provider object, which I'm not going to get into how all the authentication works in CrossPlane, but basically it goes and gets an object which has a reference to a secret, which has your cloud credentials in it. So you'll see that we get the provider, and then we get that secret, and then we create a Cloud SQL client. So That's a SQL admin service is what GCP calls it here. And then we return that back in our Cloud SQL external. The Cloud SQL external is the thing that implements the observe, update, delete, create methods as well. So in this shared reconciler, we establish that we can connect to the cloud provider. If not, then we don't continue on, because obviously we're not going to be able to take any operations there. We then do some initialization. This is related to some CrossPlane internals. Once again, can be overridden. Let's see if we pass in any initializers here. Yes, we do. I'm not going to touch on new name as external name, because that's once again a little bit in the weeds, but one that's a great example here is Cloud SQL Tagger. Cloud SQL Tagger basically just puts these default crossplane tags on every Cloud SQL instance that it implements. So with initializer is a great example of a really useful pluggable thing that you can pass into this shared reconciler, because it's basically saying, as soon as after I can connect to the cloud provider, do these things before you do anything else, essentially. And so you can basically pass anything to that. So going back to the example where you need to maybe open a ticket and check that it's been approved by a human somewhere, you could pass in a initializer, something that satisfied the initializer interface, which is very simple interface. So you can do quite anything in it. And you could check that, you can make a call out to this ticketing system and check that a ticket exists that's been approved. So it's basically just putting a stop in that reconciler and saying, hey, do these things before you go on and actually take any action on my behalf. So that's kind of a cool interface that's part of this shared reconciler, I think. All right, the next things we do is if it's deleted, or it's not deleted, excuse me, we resolve those references. So before we try and actually provision anything, calling any of these create, update, delete methods, we're going to make sure that all the other resources that it depends on are ready. This is actually pretty simple. You might think that you have to do some complex dependency tree stuff. Actually, you only have to go one level, basically, because the dependency tree basically builds itself with the references. So if you have, let's say you have the database exists in a subnetwork that's in a network. Well, all those things are represented with CrossPlane here. So, if on the database you have a reference to the subnetwork, it's not going to get provisioned until its reference to the network is resolved. So that chain kind of works itself for you. But you could get into some more complex reference resolution and pass in your own thing there as well. And also I'm actually just going to go ahead and drop this. Oh, wait, this is the one you dropped in there already. This code is very, very heavily commented. So I'd recommend either looking at the comments. It reads almost like a design doc. It's so heavily commented, or looking on GoDoc or something like that, or package.go.dev, I think is the blessed place to do that now. But maybe look at some of the things that's happening here. Next, we're going to call the observe method. So basically go see if this object exists. And if not, take some actions on it. The observe method returns this external observation struct, which basically says three different things. Does the resource exist or not? Is it up to date or not? And are there any connection details to write? And then we'll call create, update, or delete based on our observation here. So we got our observations. First thing we're going to do is check if the object was deleted. This is the object within Kubernetes. If so, we don't really care about creating, update, or deleting, except for the context of getting this object deleted externally. So what we're going to do, if the resource exists and the reclaim policy is delete, which once again, we're not going to get into reclaim policy, but you'll see we're able to get the reclaim policy no matter what the type is, because we've embedded that reclaim policy type in all of our managed resources. So we're able to call generic methods on them because they satisfy that interface. If the reclaim is delete, then we're going to call the external delete method. So in the case of provider GCP, let me scroll down a bit here. The delete method is pretty simple. It's just calling the delete on that GCP client there, and we're deleting the Cloud SQL instance and getting a result back. So if that's successful, then we'll go ahead and unpublish connection. Once again, a public pluggable thing. where you could write your own unpublished connection. So maybe if you're writing connection secrets to Vault, then that is going to be something like cleaning them up there or something like that. Our default here is going to be deleting a Kubernetes secret. So that'll be what comes out of the box for you. Last thing is remove finalizer, which has to do with how Kubernetes works when doing garbage collection. So we will not touch on that here. All right, I'm not going to go through the rest of all of these, even though we're pretty close to the bottom, just because we're nearing the end of time here, and I've drawn on quite a bit while also forcing you to look at source code. So I apologize for that, kind of, but I also think it was useful. And maybe I presume that you probably did not walk away from this thinking, I can implement this exact thing, or I want to implement this exact thing. But I hope it gave you some ideas for implementing things, and maybe it gives you some places to go look at how to use some of these technologies, as well as maybe write your own on top of them. So that being said, because that was kind of the strategy here, I definitely want you to feel free to reach out to me on Twitter, or I'm really just on Twitter, honestly, and GitHub. I guess you can open an issue somewhere if you like as well, and I'd be happy to respond to that. But I am very happy to talk about any of these things. This was kind of a baptism by fire introduction here. But I'd love to get into the weeds a little bit more, and especially talk about some of your specific use cases. I work with a lot of different organizations that are interested in using CrossPlane for their internal infrastructure and that sort of thing. So we'll regularly look at, how they provision infrastructure inside their organization, especially if it's something that's a little more unique, like a internal system for managing things in their own data center. And we'll work with them to write a provider to do that for them. And you get a lot of these benefits of things like defining abstractions and creating a service catalog in CrossPlane just by kind of providing your pluggable primitives that are used for your internal system. So if anyone has use cases like that, definitely feel free to reach out to me. Have some links here to CrossPlane Upbound, and then also doc.crds.dev has some documentation on some of those projects we talked about today. And that's a project I work on as well. So if you're interested in that, please feel free to ping me about that as well. Paul, I'll pass it over to you. I don't know if it doesn't look like we have any more questions in there, but maybe some other folks have some they want to ask, or maybe everybody just wants to go home now.
I can't imagine that, but yeah, no, that was really good though. Thank you. CrossPlane is one of those projects where I keep wanting to do something, just kind of, I might hitting me up on that to get kind of started with some of the stuff, because I'd like to kind of hack around in there and maybe contribute. So,
sure thing.
Yeah, so one of these days, I just got to find the time. It's like I don't have a podcast all the time, a bi-weekly podcast and all this other stuff. I mean, man, I'm just old, I guess. So.
Well, one of the things that you mentioned there about getting started with CrossPlane, that's something we definitely want to make a lot easier. And part of it, it's not doing complex computational things, but it's doing logically complex things, which can make the barrier to getting started a little bit more difficult. And I kind of alluded to earlier, specifically one of the other folks I work with who works on CrossPlane is basically committing all their time right now to code generation, where we can kind of generate some of these controllers for clients directly. By clients, I mean API clients. Mm-hmm. And so that would make it a lot easier. But then also just some, simple CLI tooling, that sort of thing. We'll generate like a directory for you, similar to how Cube Builder will. But there's still kind of a lot of work to be done around that. So if you or anyone else on this call has feedback about that, or just generally writing controllers, you can actually, these are I call them CrossPlane controllers. They're just Kubernetes controllers. In fact, they can actually run outside of CrossPlane as well. But we just have some patterns that we follow and maintain ourselves. So I would love to help out in any of those areas.
That's awesome. Well, looks like we got a question that came up.
Awesome. Let me take a look here. What was the comment you said about the Red Hat backed operator SDK in its future? Did you say it's likely going away? So I don't want to say too much here that's not accurate, but from what I understand, the operator SDK is not super actively maintained right now, which that may be incorrect, and you're welcome to call me out on that if so. Most of the projects I'm familiar with right now use controller runtime or their own kind of homespun controller implementation. You can obviously just use client Go, which is Kubernetes Go client, or any other language client as well, and do any of this before. What's happening basically with controller runtime is it's abstracting away talking to the API server, as well as specifically probably the most interesting thing it's doing is with the cache. So you're not actually making a round trip every time you make a request to the API server. You keep a local cache, and then those changes are committed, as is common in lots of distributed systems. And so that's the main thing that's happening here. And that's usually when folks want to get outside of the controller runtime thing. But as far as operator SDK, I can't make any official statements on its future or present status officially. But from what I can tell / think, I don't think that it's you say not looking for official. Okay, cool. Yeah. I don't think that it's in extensive maintenance anymore, used super widely. Let's see.
Awesome. So what other rumors can we spread?
Yeah, y'all can try and make me anger some people. I like to say I do, as Paul was saying, like a live stream and that sort of thing, but I strictly focus on the engineering side of things. And so there's often lots of kind of politics around open source that I try to steer clear of a little bit. But you may be able to trip me up here and there. Kube control has a security flaw. I believe you.
Everyone believes that.
Yeah, that sounds like an unsurprising statement.
But Kube cuddle doesn't.
I do know that being as part of the release team, I do handle some of the like vulnerability stuff, etc. With that gets reported. So I do sometimes see some scary things that happen. So always be wise with your usage of things. You'll have to talk to Sabri more about those sorts of things. He's more of the security guy than me.
Security guy, definitely. Me, I just use the trust protocol everywhere. I don't know. It's just the way I am now. Well, cool. So I guess that's all we've got for the questions then. But so thank you very much, Dan. That was awesome.
Yeah, sure thing. I appreciate y'all having me on. I definitely really appreciate the work y'all do, especially in St. Louis. As I mentioned, I work mostly outside of St. Louis, and that's in some ways a shame. But there is a lot of great technology folks around here. So anything I can ever do to be part of this community, as well as support this meetup or any other ones, I'm definitely happy to do that. So anyone, please feel free to reach out. I will say yes if you ask me to speak or do anything else.
Yeah, no, definitely awesome. So cool. Much appreciated.
Sure thing.
All right. Well, let me, I'll just keep you on screen here. We kind of close it out, and then, so anyway, just, if anybody has any suggestions, any kind of different, topics or whatnot, let us know. Reach out to us on that anytime in the Twitter sphere or whatever. So we'll try to get things set up. unfortunately, keep up the social distancing. Don't isolate alone. We have the St. Louis Tech Slack that we're just a part of, and just one channel in there. But yeah, don't do it alone. And now, what everybody's stuck around here for now is for the giveaways. So. JFrog and Tally, they set us up with we've got about 3 different we've got 3 of the t-shirts, the JFrog Go t-shirts. Ari will make sure that they get to you. If international just takes longer. So I guess we're going to try to do this so we've got 16 people in here right now. And Sabri had suggested maybe we try, I don't know, somehow random numbers or something here. But actually, I have on my screen here everybody in order. So I will just take, I'm going to do 3 numbers in random. And I'll call out your name here. Let me do random 1 to 16. All right. So let's see, whoever's number 15. So, all right. So, and I'm totally doing this name bad. So I apologize. Utkarsh Mani Tripathi. You'll get a shirt. Let's see. Next one is 13. So that is, he's on here as James 5464. That is, do I have a real name? James. So yeah, so if you and Utkarsh want to give me your info somehow in here, you can private message actually the St. Louis Go meetup if you are on the Twitter sphere. And one more here, number 5. And number 5 is David Jacobs. So yeah, if you guys want a direct message on, if you have Twitter, it's STL Go Meetup. And then I will get your address and your name and all that stuff. And then we'll get those sent out to you. And then I believe that Sabri has something from the CNCF, some nice swag. Sabri, you're on mute. You weren't ready. I caught you off guard. I was trying.
There we go. Okay. Okay. So continuing on with the raffle, we have 2 $35 gift cards effectively for the CNCF swag store. There's some new stuff on there, including project-specific masks, if you're into that. So you can wear Kubernetes on your face. Yay. And other things. I'm trying to weasel $50 gift cards. So we'll see if I can do that. So yeah, we can just pick 2 people and then get their email addresses and I can send them to folks.
Cool. All right. So just do another random generator.
Yep, that works.
Yeah, this number got called already. Lucky 13. All right, number 11. Oh man, that makes me have to count a lot here. Okay, let's see. They're going with Marquise Johnson or Johansson. So you are the lucky winner. Yeah, there you go. Let me do the let me mark these so I know who gets what. So
that's awesome. Marcus has done a lot of work on CrossPlane, so it's great.
Oh, okay. I'm sorry, Marcus. Did I say Marcus?
No worries. It's okay.
Yeah.
He's a very amicable guy. So
okay.
No, Marcus is awesome, and he's done a lot of community engagement stuff as well. So glad he could make it.
Oh, good deal. Yeah, so you bring your own crew to these things too, right? Okay.
Well, Marcus, and I think there was a few other folks, maybe, but I tried to.
All right. Well, yeah. Now it came up as Sabri, so I don't think. I got to generate another one here. All right. So this another one for David. I can't do that. So here now we've got Todd.
Broke up a little bit.
Or maybe do we have any? What's it?
Maybe I'm breaking up. I didn't hear that.
Oh, looks like Todd Lewis. So he's one from our normal group, I believe. So yeah. Marcus stalked you, Dan. Awesome. All right. Well, I think that was it then, right? On all the giveaways.
Yep.
Not like Oprah says, we all don't get a giveaway.
I'm going to try to. I mean, so the CNCF is new to a lot of things because of COVID-19. Let's put it that way. But I'm going to try to, because we have a budget for swag every month and pizza and stuff like that we're not using. So I'm going to try to make that more of a regular thing for at least this meetup. So that'll be cool.
Yeah. Well, we just need face masks now for CrossPlane with that the ice cream bar, right there on the mouth.
Well, I will say, so today we submitted a proposal to join the CNCF. So maybe soon you'll be getting one of those.
There we go. Yep. All right. Well, awesome. All right. Well, that's it then, everybody. Thank you so much. And next month will be Wednesday, June 24th again. And then we're going to have John Corey. I caught up with him. He's out of the Atlanta Go meetup. And then he's going to give a little discussion about gRPC and protobufs. So that'll be pretty cool. So another CNCF project, gRPC. So that'll be pretty cool. So. And with that, then, I guess, cheers. Everybody, please stay healthy, and then hopefully we'll see you all next month. So have a good one, everybody.
Thanks folks.
Bye-bye.
Thanks for coming out.